Йдемо на англійську. Мова, якою буде проводитися цей вебінар та воркшоп, тому without further ado, okay? So first of all, the kind of purpose why we gather here is to discuss and see how the chatbot testing is conducted, and maybe give you some tips, some advices where if you start or look into testing chatbots, maybe some reference to have. And thinking about how to start our workshop today, let's say I thought of different beginnings. First of all, let me introduce myself. I am Oleg Rudko, team lead in the Amelia company, which is an international company which works more than 20 years creating chatbots for different call centers. We among the world leaders. Our solutions are, let's say, deployed, installed in the companies of the Fortune 500 list, and let's say in the top of this list. One of the most renowned projects we have is installed in Royal Bank of Canada, kind of the primary bank in Canada, kind of our the best customer. We have the most of our technical implementations and solutions installed, and we are very proud of kind of achievements we've made so far. I'm testing chatbots for 3 years already, and have some, let's say, information to share with you. So what we should start from, I guess we could start like why chatbots are so important, or what makes them so different from testing any other application. And I decided to stop on the next one. So why do we even care about such user interface as conversational application or a chatbot? Let's say it seems not so very fast or reliable. Nevertheless, such large tech giants like Google, Amazon, IBM, they keep spending millions of dollars into research and development in this field. I'll provide you my answer to this question, and we will try to keep it in mind when we go to the testing part. So I believe, and let's say a lot of people believe, that personal human interaction, like conversation, it seems to be the most intimate and at the same time the most luxurious user experience that the company may have with the customer. And as such, it gives customer the feeling of extra care and having a premium care, okay? On the other hand, we have like traditional channels of customer support, such as call centers, and they are really expensive actually to maintain, and they require enormous amount of resources. So it is a natural idea that some idea to start substitute humans with some sort of automated system. So such idea should appear, and it appeared. As you know, the predecessor of modern chatbots are IVR systems, or interactive voice response. You know, all our favorite system, like press 1 to give us all your money, press 2 to give us all your organs, and press 0 to connect to a live agent. We all love them. The problems are obvious. Caller almost always has to hear tons of unnecessary information before it gets to the menu they need. And at the end, most of us, we prefer to finish speaking with a live agent and not with the bot. Kind of keep that in mind when we start speaking about testing. Now closer to our topic. On the one hand, as a QA engineers, we want to verify the technical implementation of our system, of our chatbot, is done according to the documentation. And on the other hand, we should validate the solution really solves the business problems in the best possible way. If you try to Google how to test chatbots, you will get a lot of results on how you should design them, like their persona, and the question should be open, and all this stuff. In other words, most of the articles cover the validation aspect. I'll be honest, it's important to validate that you build the correct solution, but usually it's not the main focus for us, for QA engineers. What we're concerned about is verifying that the chatbot is built as planned. So let's dive deeper into the topic of how we are going to test such thing as a chatbot. As you can't eat the whole elephant, you can't test the whole chatbot. The key to success is the composition, as always. And the classic components of chatbots, you see them on your screen, are ASR module, NLU module, Dialogflow module, and your custom component. All those comprise a chatbot. So ASR module stands for Automatic Speech Recognition. This module transcribes sounds pronounced by caller to meaningful words. And sometimes it can be tricky. Just out of curiosity, how do you think is it different to differentiate word card as a banking card and card as a card where you put all your goods in e-commerce website? The answer is yes, it is very difficult. Next one is NLU module. NLU module steps in after the ASR, and its purpose is to get those words transcribed by ASR and extract kind of the main idea that was put into the phrase, so-called intent. And if possible, to also extract some additional information, which is called entities. I like using the example once provided by our director in his presentation. So here like the story of the caller. So the caller says, yesterday I went to the pub with my friends and got drunk, and then I met a girl. We went to a beach where I lost my pants. I woke up today, I had a hangover and I can't find my card. What should I do? Behind this all funny and lengthy story, we actually need to understand that the user intent is to tell us that probably user lost his banking card. And NLU module should be able kind of to analyze this whole lengthy utterance and extract the information. Next module, which we will talk about, is Dialogflow. Dialogflow is a module that adds context to your dialogue. Let's say when out of sudden I tell you that we're all gonna die, most probably you will think that I'm out of my mind, I'm not okay, I'm nuts. But if we're discussing the Netflix movie Don't Look Up with Leonardo DiCaprio, the recent one, then this phrase suddenly starts making sense if we're discussing the plot of this movie. Similarly, if I say yes, it doesn't tell you anything. But if I say it after your question, did you buy the tickets to the movie? It miraculously provides you the information and answer to your question. This happens because our conversation has a logical beginning, main idea, some context stored through this conversation, and it goes to its logical ending. And the flow module is kind of handles all this information and all the context and development of the conversation. And last but not least, we have a custom module. It connects the conversational part of your application that is simply a user interface to the backend of your system, where some things should happen, like account balance is retrieved from database, an order is processed, connection to a live agent is established, you name it. There could be the variations to that scheme I showed, like you may not have ASR if you have like a textual bot, a web chat, but kind of classical explanation is the whole flow when you hear when application hears the caller, transcribe the voice, understand what was said, and then answers to the caller with audio prompt. So we will stick to that one. Okay, great. So we defined our test object, potentially decomposed our system a little bit, but it's still not clear how to test that. So let's go further. And we start with ASR because this system, it meets the user. So ASR, first of all, let's define the evaluation and exit criteria. So to what extent we should test, when we should stop testing, and so on. For ASR, the most common metric is, let's say, in different ways connected to accuracy of your model or precision. One of the most popular metrics is word error rate. It is calculated by dividing the number of all words transcribed incorrectly to number of all words really said by user. And it can be expressed like absolute number or as a percentage. The best possible word error rate you can get is 0, which means that model predicted all said words and made 0 mistakes. Now if we think what is the worst word error rate we can possibly see. If I ask you this question, most probably you will think like numbers like 1 or 100%. Surprisingly, sometimes the model can go even higher with word error rate. Sometimes the model can transcribe one word as, let's say, a number of small words, smaller words, or insert some words that were not even said at all. As an example, if you said university and model transcribed your phrase as unit wasted, and kind of invented 4 words instead of 1, in this case, word error rate is 400%. Of course, if you are not a small portion of students that actually waste their time in the university and do not study, but even in this case, the model is officially wrong. So after you identified your exit criteria or proper level of accuracy, precision, once again, this metric is slightly different. You can actually Google it really fast. When you defined your final metrics, you can start so-called back-to-back or differential testing. With this methodology, with this approach, you use the current version of your system as, let's say, a pseudo oracle or a reference, and you compare the outputs of the model, artificial intelligence machine learning model you train with existing current system. And if system under test demonstrates better results in terms of overall metrics, the accuracy, average accuracy shown on your sum set test set, in this case, is kind of a good candidate to deploy as a new version. And if it shows worse results, in this case, we kind of discard this version of the model. And when we are assessing the model, it's important to remember that total accuracy on the whole set is more important than accuracy in individual cases. I mean, you may see the situation, let's say your model, you have a current model that accurately recognizes, transcribes 80% of your test cases. Then you bring another version and it recognizes 90% of test cases. But all the cases that it got wrong, they all contain error, and they all contain error as a regression. So those tests were passing successfully in previous system, but now they are not recognized. But overall accuracy is better. In this case, probably this model is a good candidate to release, and we should prefer it over old model. Okay, let's say we set our exit criteria. Let's say we want to achieve average word error rate in our whole test set below 15%. How do we get the test data? Yes, and important thing to mention, testing AI and ML models, both for ASR and NLU, when you have these artificial components, is all about data-driven testing. So kind of the test case itself, it's just to say the phrase and assert what was transcribed. That's all. No fancy steps kind of to do. All about getting the correct data. And when we speak about testing chatbots, the most ideal data you can get is real calls recorded by real customers. It can be collected using a previously installed IVR system, customer support system, ticket system, whatever source of information you have for the real data from real callers. Use it, because it's way more precise than any source of information that well-planned, structured, normalized, but the data is synthetical and created by development or testing team. Because no matter how kind of good you are, the expert in the domain, you won't think as kind of your average customer, average user is kind of the law. So prefer real data over synthetic data. And no matter what data you get, you should normalize it and filter before using it as your test cases. How it can be done? Usually model has some well-functioned core pre-trained in the previous models to a certain degree. That's why we don't usually focus on common words in our test cases, like questioning parts, modal verbs, different ways of prepositions, pronouns, all that stuff. What we are interested in when we are training a model is training specific vocabulary needed to transcribe certain domain. For example, in banking, it could be words like bank, account, card, transaction, balance, transfer, and all of those. As you have the list of those, you can apply equivalence partition technique, considering that every word is a valid class. We don't use each word separately in our test cases. Sometimes we do, but not often in our test cases, but we combine them into meaningful phrases, such as the phrases that could be really said by our users, but by our callers. And these phrases really should make sense and not just be some, let's say, combinatory bullshit. Sometimes the vocabulary may reach, in this case, hundreds, if not thousands of test cases just on this phase of testing. So if you need to shorten it, you can combine different keywords together. For example, if I say, I want to know my account balance, I use both banking words like account and balance. So I can combine them into one test case and reduce our test set, by kind of making our utterance more complex. But don't overcomplicate, stay within reasonable, meaningful utterances that could be used by a real person. Okay, in case if you don't have real data and you have to invent them on your own, I propose you to use pairwise techniques. Here you can see, so what we need to do, we have a phrase and we need to decompose the phrase into logical blocks. Here you can see that I decompose into 3 parts: request, can I, action, communicate, speak to, and live person, meaning live agent. So now, as I have these blocks, I can apply pairwise technique. Every block will be a category in pairwise. And for these categories, I will pick up synonyms, which I could think of. And we have this pairwise table. You can see that I used this free online tool, Pairwise, and you build your synonyms. If you go to all unique combinations of these words, which actually is not much, for real application, I would try, I guess, to go with 7 to 10 synonyms for each word. But even here, we have 48 total combinations, and we can reduce it using Pairwise to 16 paired. So it was done by me, and you see the list of these 16 combinations. After I got this list, I go through them and, let's say, mark some combination that doesn't make much sense to me, or maybe sound not so good. So here I reduced these 5 cases you see. Like, can I connect me to human, like some gibberish? So I decided to move it out. And as a result, I got 11 test cases. When you have your list of kind of these phrases of these cases, you can do something that is called metamorphic testing. Metamorphic testing means that you make small changes to your phrases, small like beautifiers, adding flavors. I underscored every of them here, like an article, word please, me, any. So it makes your phrases, let's say, sound more naturally, more human-like. And at the same time, they kind of make small distractions for your model. And because of that, the model gets trained because of that. So this kind of a test set you could possibly get just thinking about this phrase and how to handle it. And when we speak about training the model, the more data we feed to it is better. But in testing, if you remember, we get kind of the opposite goal. We want to test the system more completely, but with fewer amount of tests to save our resources of different kinds. If we remember, one of the 7 principles of testing, that exhaustive testing is not possible. So we want to find that data that kind of with less amount of test cases would cover more functionality. Yeah. And in this case, you ask me, how many test cases do we need? And my answer is, it depends. But the size of your unique words in your vocabulary is kind of a good reference. So if you have like 200 unique words, probably you should start somewhere around 200 test cases and see how it goes there, because model is not something that trained once. Probably you will have different iterations and compare different models. So yeah, like every unique words covered by a test case is kind of a good place to start. Okay, going to the next slide. So as you know, defects, they cluster together. Yeah, and another principle, one main principle of testing. So when we have clusters, where we have clusters of defects in the chatbots, in the ASR specifically. First one is homophones. So you see words 2 as a number and 2 as a preposition, 4 as a number, 4 as a preposition, card and card. So those sound identically, but written differently, and they have absolutely different meaning. So this is your first source of defect, and it's really hard to solve that. Every time the solution is completely different. Sometimes you train NLU to help you, so you know that ASR will do fails here, and you help NLU to understand kind of both variations that can be brought here. Sometimes you, let's say, discard all the prepositions. Like you don't have to as a preposition in whole your dialog. It never understands that. But to as a preposition probably won't break your cases, and the system will be understanding the meaning. But in this case, you will start handling the number two, which is far more important and probably will be used more in your application, like in authentication. User will be telling you some numbers of their social security number, date of birth, and whatever, and two is met more frequent there. Okay, next similar cluster of defect is near close sounding. Like try to play with these words like bank account, banking card, bank account, banking card. So they're kind of similar, and especially if you have we deal not with the ideal sounds, not ideal data. It's not high fidelity. It's kind of sent to us over the phone. It may be up to, let's say, 8 kilohertz, something like that. So the bandwidth is short, or the rate. And because of that, the sound may be distorted. So it could start similarly. So branch, bench, at 8H. So yeah, really a source of another defects. Another thing we can struggle at with ASR is accents. And the answer here is, or device is simple: know your user, for whom you create your application. So let's go with English. British English and American English, completely different. Okay, even if we take United States, like northern states, New York, and southern states like Texas, Nevada, California, when you have a lot of Spanish speakers, completely different. Once again, the South, let's say Texas and Louisiana, with their Jamaican singing accents. So once again, the colors will be different, and you may be asked to bring an application for specific city, specific state, specific country, and you should know all the kind of peculiar specific there in pronunciation. Another potential source of defects are non-verbal sounds made by human. Like you see, I'm using this non-verbal sounds right now. I'm hesitating a lot, saying thinking this all meh also adds as articles, or sometimes it even creates some new words you couldn't think of. And we can produce other sounds as well, like coughs, sneezes, or laughs, and all that stuff. And last but not least, you should think about sound contamination that you can get not only the voice of the caller, but also all ambient sounds, some music, some background voices, all this stuff. Let's say if we speak about creating the bot for some fast food chain supply restaurant like McDonald's, then probably we will have a lot of background noises and music. If we create the chatbot for the same McDonald's, but for drive-through, their McDrive, in this case, we will hear in the call a lot of car honks, like engines revving, tires screeching over the asphalt, all that music. So probably the bots and ASR trained specifically for the outside, and for the inside, those will have different acoustic models, because you need kind of to take into consideration this sound contamination. And in the test, you need to reproduce actually this sound contamination as well. You should launch some kind of background noise for yourself in order to replicate it adequately. Okay, so final thoughts about ASR. I repeat, the most important thing in testing anything where ML machine learning model is used is don't use your test data to train the model. I can't really tell you how easily the ASR team gets your test cases and feed them to the model. It just happens all the time. What do we get as a result? The model demonstrates kind of 100% accuracy. The word error rate is completely zero, but it's not because the model is so great. It's just because it's trained and specified specifically to your test data. So the model is biased to your test data, and you kind of can't use it anymore. You need to create a new test set, like slightly different, make this metamorphing stuff. And considering the amounts of data we usually create for this test for ASR, it's not something we actually dream of. Next thing is as I said, find real data by all means. I have a case where, as I said, we created a chatbot for one of the fast food chain suppliers, and we became really expert in understanding all these ingredients and all the products, like all the sort of mayonnaises, ketchups, hamburgers, potatoes, coffees, whatever you may say. It understood everything correctly. But we were not given the real data at the beginning, and we started training the model. And then, like a couple of weeks later, we finally got the data, and we were shocked because people were not saying like, "Give me the hamburger" or whatever. They were saying like, "Give me 2 number 9s and 2 number 6," and it meant that they have some, let's say, discounts for some specific pack. And people just ordered this pack. You know, we also have this, like in McDonald's, this application when you have this discounts. So people were just asking these discounts by numbers and not by ingredients. And it was kind of a huge reveal for ourselves. We adjusted the model nevertheless, but it was a shock. So if you just have only synthetic data, sometimes your model may kind of miss the scene completely. Another final thought is tune your model after release. So the specifics of the chatbot testing, it's not ended with your release to production. Release to production is a kind of necessary thing to develop your model, to train your model further. It's always taken some period of time. It could be weeks, could be months. When you tune your model on all real customer data, you start to seeing these cases you didn't think of when you were testing it in your development or staging environment, and you could find that only on the production. So always tune your model after release, and even with the time, the model gets, let's say, less accurate because of so-called drifts. It's called concept drift or data drift. For example, we had a pre-COVID era. Nobody heard of COVID. What is that? And suddenly people start calling and asking about COVID-related things to the banks. Like, can I visit your bank without a mask? Or do I need to get vaccinated to visit a bank? Something like that. It was not a word about the vaccines, masks, and COVID in our models. Yeah, in models. We had to retrain them to understand these new phrases. So this is called a concept drift, and it's happening all the time in the production. So periodically we need to tune our models because of these kind of changes in our customer behaviors. If you create a chatbot for, let's say, e-commerce website, so you will have a Black Friday, it's completely another universe comparing to the other stuff. Yeah, when your site is working, you can have like some advertisements, some discounts, whatever, and the concept because of that may change as well. New goods may be presented once again. If we would like say testing something like Rosetka, and we have like a lot of medical equipment starting kind of getting sold, and people asking about that. So yes, once again, and we need to train model to get better to that. So I guess this kind of concludes our part related to testing ASR module. So let's make a pause, and if you have any questions specifically about ASR, it's a good time to ask those. So. No questions so far? Okay, in this case, let's go to NLU. And a couple of words about how NLU really extracts the meaning of the transcribed phrases. It scans your phrase and classifies the words met in this phrase according to the vocabulary, if trying to find certain entities. Entity is something with a distinct and independent existence. Like in our phrase here, banking card is an entity. Cards, they can be different. They can be Visa, MasterCard, American Express, Discovery, but they all belong to one entity, banking card. The same goes for banking account. You can have different type of accounts, card account, operational account, deposit account, and all of them fall under one entity, banking account. You can see here entities like service, balance. Yeah, another service we could think of is, let's say, history of transactions or money transfer. It's also a service. So those are different entities that kind of give us meaning about what user says. And this concept may be a little bit confusing at first, and it's somewhat similar to equivalence class, but in fact, it's not. To make things clear, let's talk about such entity you must probably have, will have in your application. It's called action. So let's think of the next list of verbs: take, get, transfer, deposit, know, schedule, cancel, assign. So even without kind of being an expert in chatbots, you understand though that those words, they're different, completely different. You know that they will cause system to act differently, and if system acts differently because of those, they can't be equivalence class. But because equivalence class, it relies to similar inputs, provides similar outputs. Yeah, in our case, the output will be completely different, so they can't be an equivalence class. So in this case, what makes a basis for our test cases and for our equivalence classes? It's an intent. Intent is the main idea, or I must say purpose, that user put into their phrase and that your application, your NLU, must understand. For example, if user says, I'd like to know the balance on my Visa card, then intent is card balance. So what user needs is to get the balance on their card. Intents can be extracted from the phrase using certain rules or according to trained models as well. Or can be a combination of both of them. Let's talk about rules here to kind of understand more the concept and how to test it. So once again, we have entity card here and entity service. Probably the word balance itself is self-explanatory, and if user says balance, probably it's about getting the balance on his card. Yeah, card balance we know because we have entity card. If the word no card word, I want to know the balance, my balance. In this case, we would trigger intent balance, and then we will specify balance for what you want to know, kind of your account, your card, your deposit, for what the balance, and user would say it. But we have entity card and entity service, and because of these two entities, we know that the word is card balance. So it's a rule for us. If you see balance, if you see card in this word, probably the intent is card balance, and the rules can be different. And every rule can serve you as an equivalence class. So the rule is, you see balance, you see card, that's the card balance. That's the rule, and we need at least one test case to cover that. And yeah, about this one. So when we test here, we know also we extracted the entity card type, and we know that the balance is not specifically on the card balance, Visa card. So if user has two cards like Visa card and MasterCard, we know where to look specifically. So it's kind of good to extract additional entities because you may use them in your dialog further. But let's go to another rule. Second phrase, I can't see the balance on my card. So balance and card should trigger card balance, but I see the word can't see, and specifically this can't see, this negation in the word can't, and we could think of synonyms here like don't, doesn't, mustn't, and something like that. So I marked specifically for the sake of presentation them as entity troubleshooting. In real model, it can be marked any different kind. I think not the troubleshooting, but we marked it here. I can't see, and because user has this some negation, like some problems here, some issues, having this entity troubleshooting with entity service, and we know that it won't be a card balance anymore. It will be a card troubleshooting. So this another rule, which leads us to another intent. Yeah, so once you kind of create all these basic rules, you kind of start categorizing your NLU and creating test cases for that one. Keep in mind that identifying correct intent is much more important than identifying correctly a lot of entities, like 10 entities, but you missed the intent is bad. Because entities sometimes provide you additional information, but if you miss the main idea, the main intent, like I can't see the balance on my card, and the system thinks that it should announce the balance, but the problem is that user can't get their balance. Okay, so it completely misses the flow and it frustrates the user. It goes with, let's say, a lot of denials, users hanging up their phone, which kind of reduces the statistics, and people not satisfied, businesses not satisfied. Okay, so final thoughts about NL use. As I said, intents and entities. Intents are more important than entities. Yeah, another important thing about entities and intents, word order matters and distance between your entities matters. In our case here, I'd like to know the balance on my Visa card. If you remove word Visa and you shorten the distance between balance and card, this will be a completely a new rule, not handled by your model. At least it was the case. I last worked with Dialogflow from Google. It was the case. So if you have kind of 3 words between them, 2 words, 1 word, is different rules, and you need to create all those rules. If you just change the word order, like I want to know my card balance, it will be another rule. Okay, you need to train model to that one as well. And yeah, the kind of this rules really create some complexity to train your model and to test it. As I said, for sanity testing, for smoke testing, it is good to create 1 test case per intent. But for better coverage, for the coverage you actually want to achieve, all rules should be tested as equivalence classes at least by 1 test case, and sometimes you may have like even more complex cases. And when you're training your NLU module, like adding new entities, adding new rules, it often, not often, it's almost always breaks all existing system of intents, because rules start, let's say, conflicting with each other. So regression test is a must-have in this case, and should be run, let's say, should be run often, and maybe even moved like to unit test closer to the developers. But yeah, regression test is a must in an NLU model. Okay, so once again, I think this summarizes the NLU testing, and we can leave the part related to ML and AI, and we'll go to more traditional, nevertheless complex thing. So if you have any questions so far, once again, I would gladly answer those. I see that you have some questions in the chat. I missed those from the beginning. So we can use nonverbal sounds for sentiment analysis. What do you mean, like people crying or laughing, something like that? Let's say in the models in the chatbots actually produced for the commercial system, it's not so often kind of to do that or makes a decision. Let's say business just don't need so complicated models. When you actually into this, the model are pretty straightforward actually. And of course we could use this verbal sounds to get the sentiment. Let's say we use also with voice biometrics, and in voice biometrics you can handle such, let's say, data and somehow process it, but I never used it working somewhere in the commercial system. It's like more like experimental data so far. Just testing chatbots on different platforms like Salesforce. What kind of the question specifically? So integration part of your chatbot or conversational part with, let's say, any custom module you have, like passing the data there. So usually it's done through some sort of web service. Probably you will be passing JSON information in JSON. So it's a mere API testing. It's kind of the simplest part. I never had problems with testing that, and that rules testing API most often applied. So yeah. So if you don't have questions, we go to Dialogflow testing. Okay, the flow. If you worked with a chatbot and analyzed real customer data, you know how much nonsense we can get in the dialogue. people may try to harass the system sexually, ask questions related to the quantum physics. They can sing and do a lot of crazy stuff when they were just supposed to make an appointment to a doctor in an insurance company. And despite us being so weird and unpredictable, more or less we expect dialogue to have, let's say, some logical flow and to have some common patterns. Every dialogue starts with an opening question from the system, like, how may I help you? Then user replies with the purpose of their call, and the system tries to fulfill this purpose, or if you remember, not a purpose, but intent. While we do that, the dialogue goes through different states, which are logically connected with each other, and some information moves along with the dialogue in form of context. So yes, doesn't mean anything. Do you want me to look to an appointment for you? Yes. Now it starts making sense. The context in the dialogue is stored in form of multiple fields containing intents, entities, different counters, including error counters, information retrieved from different services, including caller phone's number, timestamp of the call, information from the database, and so on. And combination of these values and statuses in these fields allows us to move dialogue into different states and clearly understand where to go next. About quiet parts, I will answer after the dialog flow at the end of our workshop, okay? So, diagram. So this kind of, you see a graphical representation, so-called flowchart. I guess, I think it's the best way to represent kind of the main idea of your dialog flow. Usually, especially if the team is not experienced with that, you may be provided the cases in form of use cases, user scenarios, or even maybe some tables where some, let's say, phrases somehow categorized. But the flowchart, this graphical representation, is kind of the best way, because it allows you to catch different interactions in the system, which otherwise you may miss if information provided in some another way. And flowchart itself, let's say, it's some of the form of representation of state transition diagram. And we know that state transition is kind of a testing technique, and especially this technique is applied to test your flow. So we have a flow chart. Let's go through it and understand what the scenario is. So first of all, the user calls and the system greets user, welcome to XYZ Bank. How may I help you today? We have no intent here, no stored information. User tell us that I want to know the balance on my card. We ASR transcribed, NLU understood the intent, and we store the intent. Intent is card balance. And we have a default field for authenticated, and it is false. Yeah, and as soon as system gets these fields kind of combined together, it has a conditional for that. It checks it. It understands where the dialog at the moment, and it understands that it needs to authenticate the user. So system replies, got it, I can help you with that. In order to verify you, could you tell me last 4 digits of your social security number? Okay, user tells it's 1234, and the social security number is stored in another field. And as soon as it is stored, system understands that it can move further and ask for date of birth. Great, now I need you to tell me a date of birth, April 1st, 1984. Okay, the data is stored once again. Then as system knows that it gets all the data, all authentication data it needs, it knows that it should ask a database for and find this user. So we have some backend call, and let's say user was found. In this case, if we found the user, we authenticate this user for this call. And once we get all this information, we can retrieve the information from the database, and we know that the balance is $132. So thank you. The balance on the bank card is $132. After the intent is fulfilled, so yeah, once we announce this, we change the intent status to fulfilled, and the system understands that basically it did what it was supposed to do. And after that, almost always, the system should ask user if user wants to proceed. So we ask, is there anything else I can help you with? And after it asks this question, it clears all the fields. So we once again have no intent. User in our case tells no, that's all, thank you. And it's kind of end of dialog request, which is true. And thank you for calling XYZ, goodbye. Another thing, we have another kind of branch here, another scenario. Intent is card balance, but user is not authenticated, false, and we have all the numbers, and the backend call was done. So we kind of got some error code from our database, not that it's from the backend. And if we have this situation, we answer to user, I'm sorry, but I couldn't find any match with this parameter. Do you want to try again? And if user asks yes, we kind of confirm that user wants, and we go back to our authentication. If no, once again, to no else, and that's all. So this kind of dialog is pretty simple. If you have more, let's say, like services for your bank, so you will have another intent here with another flow, another pass for this intent, and you may have, you will have multiple intents of such kind. So it's great if business analysts provide you with such information represented, but actually it brings us, let's say, not so much information we would prefer to see. I will show you soon, but let's start even how we would test this one. So if you remember state transition, we need to test all kind of transition between all possible states. In this case, we should go first this branch, which is a happy pass, and announce the balance. Then we should go through this where we have some error user. This will be second test case. And the third test case would be to user saying yes, and we go through the authentication process once again. When you create test cases for flow, keep in mind that the flow usually is kind of one of the latest stages in the testing. Usually ASR system is ready, NLU system is ready, and you do more complex end-to-end tests. So in your test, you should start with the beginning of the dialog and finalize with a logical end of your dialog. It doesn't make much sense kind of to break your dialog here, because let's say sometimes you will, in this case, if you stop it here, maybe some issues can occur here, and if you don't look to them, you may have some problems. So logical end-to-end testing in your dialog. Okay, so 3 dialogues so far. What we could miss here? Let's think about the coverage which we can do when we test the code itself. So first, we start with a statement coverage. In this case, we have 2 statements like saying the balance and saying that no authentication was made. So we need 2 test cases. Yeah, in this case, we miss this loop here. In order to go to this loop, we should apply decision coverage. In this case, we should go to every edge or every arrow in this diagram. And in this case, third test case will discover this pass to test. Can we go further? Yes, we can. We can go for loop coverage. Loop coverage means if you have some conditional, some looping in your dialog, you need to go the condition when you will go out of the loop. And even now, we understand that we have a potential defect, potential bug right here, because we don't have a condition how to go out of loop. So we have right now in this diagram, we have an infinite loop. Infinite loop is something that you want to avoid in your application. Is the worst case scenario if you put your caller into the infinite loop. It pisses people off. So yeah, it's something we should think about the first time. And the highest coverage which we can achieve is the path coverage, when we are kind of creating unique paths, even if a lot of stages are repeating, the path kind of minorly different, and it another test case. Let's say path coverage, it's not something I saw very often in the commercial applications, because usually they're huge, and the path coverage combination, they will be in thousands, maybe if not millions of test cases. So it's not something that done usually. About sharing documentation, this can be shared. Yeah, I think we will add this to the presentation as well. I have a transcript of what I'm saying right now. I can share this document as well. So it is given to us as a QAs, and we need to do some stuff, well, some static testing, some review of this documentation. And after review, this document will look like this. You may think kind of this is completely different stuff, but no, it's something reviewed by a QA engineer, and QA engineer just thought of some test cases that business analysts didn't think of. So yeah, this is how things got complicated after the thing goes to QA engineers. Okay, so first of all, you see that I added some logical blocks, like starting the dialog and ending the dialog, highlighted in yellow color. It is important when you have like a production level of system, you will have a lot of these calls, a lot of different situations when the call may end to different sort of errors, to different happy passes, and the diagrams will be huge. And if you don't have this kind of logical endings and logical beginnings of your dialog, you'll get lost in your diagram. So please do that. And actually, you can see that in my diagram, I help myself a lot with kind of graphical elements. So for example, all system prompts, all things that bot says, they are marked in green rounded rectangles. Yeah, everything that user says us is in blue parallelograms. All logical places are in red rhomboids, some of that. And overall, the flow goes in one direction from the top to the bottom. So you can understand how close you are to the beginning of the dialog or to the ending of your dialog. And if you go to the loop, you understand that you actually go a step back. Yeah, it's kind of important to understand as a QA engineer, because sometimes, once again, not experienced analysts or people who create such diagrams, they create diagrams that go in all directions, going down, then shifting to left, then up, then right, then once again to down. They use it to kind of use all the space in their sheet, A4 format, yeah, something like that. So they just want to leave these places, but this is a complete mess. It's really hard to read such diagrams. So please use the one common direction, either bottom, top to bottom, or maybe left to right. It's up to you how to do that, but follow this. It will be more structured and much more easier to test one. So we're going to our diagram. So why it got so big? Because we thought of actually negative test cases, and as you know, happy pass is just a couple of test cases always, and negative test cases it's the majority of our test cases. So we could think of here when user is supposed to tell us their intent, like balance on my card, what actually can go wrong. User can ask for an agent, and this is a logical scenario, something we actually do when we are calling Privatbank, Nova Posta, and all that stuff. User can ask for an agent. User can kind of provide us no input. No input is a situation where user didn't tell us anything, just was silent, remained silent. Why it happened, we don't know. User just, let's say, was speaking with someone and missed his time to tell you something. Maybe he was muted in his device and forget about that. God knows what can happen, but we get a no input. Okay, the situation happens. Or we can get a no match. No match is a situation where we try to map this utterance across all our intents, and we didn't find any suitable intent. In this case, we kind of have a no match. And when you have such situation, you should have some fallback. The system should kind of behave somehow and not just stuck on this step when it didn't recognize what user said. So we have the situation here. I made them simple just for the sake of the presentation. So once we get any of these error scenarios for the first time, we give user a response like, before I connect you to customer support, could you tell me purpose of your call so I could help? And then get back and waiting for user input. And if user goes second time here, then we can understand that user actually requests customer support, and we tell him, please hold while I'm connecting you to customer support team. And we transfer this session to a real call with the customer support. And by the way, this is the way how you should bypass actually chatbots. Not need to say like, needs to say something that should confuse the bot, like the atomic mass of uranium is something like that, or what is your atomic mass of uranium, or where the Chernobyl catastrophe has occurred, something like that. Not needed. Just say agent, agent, agent a couple of times, and you will go through to right to your agent. So in no input and no match, we have kind of similar situation. The first time we kind of we don't despair. We ask user, I'm sorry, but I didn't get that. Could you please repeat again? And if user has the same issue, we once again transfer it to the customer support team. Okay, done with that. Another scenario that was added by our QA engineer is this logical step. User is authenticated already. Oh no. Sometimes you get users authenticated just through their phone numbers. Sometimes maybe the user provided you maybe some information. If it is a web chat, maybe user provided you some information. Maybe he logged in already into your website, so you understand what the user is. And in this case, if the user is authenticated, you can skip the step. Or maybe user told you the authentication in his previous intent, and this is the second question about the balance he's asking. So the user is already authenticated. If this is the case, you just can proceed to telling user their balance using this authentication data and retrieving from the database the balance. If not, we proceed to the step we told about before. And what can go wrong? And for example, when user is saying social security number. So once again, user can tell us incorrect number of digits, not 4 digits, but 3 or 5 or 6 or whatever. User can tell us non-digits, like, I'm sure, anything but non-digits. User once again can be silent, can ask for customer, can start ask to start from beginning, like user understood that you start asking about the balance or going to authenticate, and user may say, no, let's start from beginning. Oh, cancel my balance request, something like that. Or even user can tell you, ask you about, can tell you another intent. Once again, user realized that it's not something happening he wanted here. No, I want it, and tells you another intent. In other words, it also can happen real possible situation. So your system should handle all these situations. I didn't didn't put this information to the diagram because it would become really big, but this is something that you should consider when you're doing a production like system like that. Once again, when we have to go into the date burst, invalid date, we can have not a date at all. And we don't need to validate it. I mean, if it's not a date or invalid date, we don't need to actually ask the database if the date is correct. We can understand it is not. For example, if user said February 31st or like the date in the future, something like that. So all the situations should be handled as well. And once again, when user time to tell if they want to try again, once again, we can have no input, no match, and customer support request. So how many test cases do we have actually here? So we have one happy pass. Let's say every user input, unique user input you need to trigger is kind of as a test case. So we have one happy pass, 2 agent requests, 3 no input, 4 no matches. This is a happy pass. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14, so this is a happy pass. Let's say 15, 16, 17, 18, 19, and 19. Let's go with the loop. So 19 tests, around 19 test cases, just to test this simple flow where somebody from the design team just told you that you need a couple of test cases to test that. And in fact, you need 90 test cases, but I can tell you that you need more actually to test that. If you test this with 19 test cases, you kind of go, if you remember how state transition test design technique works, you covered it from perspective of 0 switch coverage. So you made every transition from one user input to another user input, like from this one to this one. It's good to do one switch coverage. Extent of 0, it means you have 2 transitions between 3 possible situations. Like, let's go to the beginning. For example, first you ask for agent, and then you don't go to agent, you go to happy pass. It's one test case. You ask for agent, and then you do no input. You do no input, then you do no match. It's a different combinations, and they can bring different results. Let's say I know, please believe me, the situations when you have, in this application, you have a lot of different fields that store different sources of information. Not always these fields are cleared correctly, the same way as, let's say, garbage collectors do in different programming languages. Yeah, so we have different garbage collectors, and memory allocation and handling all that stuff. It really matters. The same way goes to chatbots in your dialog flow. So sometimes different weird combinations of different fields may actually bring some unexpected results, and those actual combinations are plausible. So for better coverage, it's good to go with the one switch transition, one switch coverage, which actually brings even more test cases. It's not necessary always, not maybe for all modules, but some modules that are reused often, like error handling, it will be all over your the one kind of piece of code, but will be all over your application. It's good to test it. Once again, authentication is really crucial module. So one switch coverage is good for that one. But maybe for the main heavy pass, it's okay to go with a zero switch coverage. Okay, we're almost kind of close to the end. Final tips and tricks, like my personal collection, related to traceability of your dialogues. A little bit more in the scale. Okay, so traceability. As you can see, you can put different requirements specifically on your dialog flow diagram. If you have like this level of requirements, like well structured with IDs and all the stuff, you could put this requirement just on the diagram, and you know specifically which requirement you are testing right now with which test case. Okay. Next thing, you can put the IDs of your test cases. Like here you see TC1 for the first test case, TC2, TC3, TC4, and on every step you can understand kind of which test case. You can put the information here, like TC5. Okay, I'm Ukrainian, like TC5, yeah, and it will be here. And we know that test case number 5 goes here. Usually, actually, it will be TC1. Yeah, Y5 is happy pass. TC1, so it goes here, and you understand all the test cases, what they do and where they go. It's cool to actually trace all your development from the requirements right to the test cases. And if something kind of need to be changed in the requirements, once again, you just look into your diagram and you understand which test cases should be done for regression. And another kind of, let's say, useful trick, you can see that arrows are of different colors and line thickness. And it's obvious that if arrow is green, it means that we run this test or maybe created this test. It's up to you. Run this test and probably the test has passed successfully. That's why the arrow is green. If the arrow is red, test cases were kind of used but failed. And if the arrow is black, it means that the test case is not executed yet. So once again, it gives you better traceability, like what you did, what you did not, and kind of how to handle all the situation. It brings more structure to your test efforts. So I guess that's all I wanted to share with you for today. So yeah, thank you for your time listening for my presentation. Now let's go to questions and answers section. Maybe if you are not confident with English, you can ask your questions in Russian and in Ukrainian, and I will answer them as well. So first of all, I had some questions in the backlog. So let me read those first, and then we proceed to your questions. Quiet parts. What are the best practices for timeouts for allowing the user to respond? The answer, so what are the best timeouts for allowing user to respond? It's kind of different situation. Usually it's somewhere around 3 seconds, 3 to 4 seconds, but it may vary. And actually you can try it with a real situation. So yeah, timeout is something adjustable. You can just put some number, try how it goes, how much no inputs you get. So amount of no inputs will tell you if it is enough for users to provide user information. So you go have all the statistics and you can kind of adjust your configuration. But once again, think of the application. For example, if the application, like for normal people, for ordinary people, probably it will be 3 to 4 seconds. But for example, if you create a chatbot for a pension fund, and you know that the callers are 60 plus, probably you would add more time out, cutting off the call, something like that. Yeah, so the idea is simple here. And always, of course, kind of think of something and then try and adjust. So this is the way how the chatbots are created. Then the documentation, yes, it will be shared tomorrow. Yeah, as I said, as we were set with the presentation. Share the tool that used for diagram creation. Yeah, the tool is called diagram.net. It's a free tool as well. It's integrated into Google Drive. So yeah, it's really a useful tool. Some companies often use Microsoft Visio, but not all of us work on the Windows machines, and this stuff is kind of paid one. So Diagrams.net is really great tool to use that. Video record and doc via email. Once again, yes, this will be sent. So, okay, colleagues, it's everything we have in the chat. So do we have any questions left, not discussed yet? I would really appreciate your questions. Test automation, of course you can't. So what about ASR, NLU, and Dialogflow testing is possible to automate? Of course, such big amounts of data, they can't be run only manually. So of course we do manual testing at first to kind of to understand what's happening, to get ourselves familiar with the domain, with the vocabulary we're using. But then the test cases are automated. As I said, for ASR and NLU, it's all about the data. So it's a data-driven development. And usually ASR and NLU module, they are accessed via API. So any framework you use for API testing where test cases can be parameterized fits well. For example, we use simply Postman and Newman put into Jenkins if we want to kind of automate and put into CI/CD pipeline. But for like when the active development is going, everything is put into the Postman. We have CSV files with our utterances, with all the assertions, and you just run. You just create your kind of HTTP request, which is the standard for all your tests, and all the automation goes from your CSV file, which you use for parameterizing your tests. It is done both for ASR, it is done both for NLU. For Dialogflow, it's kind of a little bit more complex. Initially, I plan to show you the tool called GraphWalker. It's a model-based testing tool which can be used with Python, .NET, and Java in these three frameworks. But actually, it requires specific outstanding workshop because it's kind of it requires some time. The tool is free. Once again, GraphWalker. Let me actually type it here. GraphWalker. And Python implementation is Altwalker. So try to search this one. What the tool does, basically, it uses your Dialogflow. It looks at it at, let's say, at some binary tree, and it uses some combination, not the binary tree, I think, but it has iteration, like it understands the nodes, like next node, yeah, the previous one, and you create these rules when you can go to this node and not to this one node, and then you choose like what coverage you want to achieve. Like I want to have 100% statement coverage, and it goes in combinatory ways in all possible directions according to the rules you created, and in every step. So basically what it does, it just goes to this place, and in your programming language, Python, Java, whatever, you just made another API call. For Python, I use, for example, HTTP requests library, and you just create what you want to assert there. I was asserting specifically for intent or for system prompt. So these two things are usually okay kind of to understand, and you can go through all your Dialogflow in automated fashion. Yeah, so the Dialogflow is also automated, something that can be done. Once again, if it will be interesting, we can like organize another workshop specifically to using graph walker with a chatbot, but it's even more technical. I'm not sure how many people will be interested in that one. So yeah, I don't know. Yep, it is. And actually, as this thing, so let's say, as I said, the chatbot is a user interface for users to interact. So sometimes we're just lazy, or maybe we have our hands kind of busy with something. Here, maybe we have some impairment, like let's say something is better for maybe the person is blind, something like that. And we don't expect like some, Shakespeare novels. We see this stuff as well. As I said, people are saying crazy stuff, but more or less people understand kind of how to interact with the system, especially with a little bit of training. Like on the first days when chatbot system is implemented, all users kind of have the lower rates of happy passes, let's say so. But users actually learn quickly, and you kind of see that user understand how to work with the system. So user understand how to, so the model is trained on the users and the users are trained on the models. So actually there is not much variation. The main trick is actually dealing with ASR, so really training to understand, to transcribe the words, and intents and not intents, NLU and the dialog flow. Those are pretty deterministic and can train really to good extent. The main kind of focus is about training your ML models specifically for ASR and sometimes for NLU. Okay, colleagues, maybe someone want to tell something? No, it would be really great to hear your voices, but if not, okay, I'm okay with that. I don't know also what of my information was shared. If it can be shared, you can find me on LinkedIn, I guess, as well. If let's say you need some continuation to that one, interesting to kind of share some thoughts, you can always add me and we can I can answer your questions. Maybe you could think of tomorrow or later today. Maybe it's kind of not the time when you wrapped your head around all of this. So kind of yeah. Okay, great, colleagues. If now no more questions, okay. So if no more questions asked, I thank you for your time spent on this workshop. I guess I hope it was useful for you. And once again, yeah, if the topic is interesting for you, we can think of any follow-ups, but it's all kind of up to you. And once again, I thank you for your time and have a nice evening. Okay, I'm stop sharing my screen.